We're a little over halfway through our journey understanding how traits get passed on from parents to their offspring. And now we are going to look at sex-linked traits, which are present on the X chromosome and absent from the Y chromosome. So these are traits that primarily tend to affect males more than females. Two of the traits we'll be looking at are color blindness, which is the inability to make distinctions between certain colors. It doesn't have to mean that everything's black and white. Sometimes there's a red-green colorblind where you can't tell the difference between red and green. So there's different varieties of that. And then the hemophilia disorder. And hemophilia is when your blood has trouble clotting, and you can remember that, hemoglobin. And that can be very dangerous because you can either cut yourself and keep bleeding or have internal bleeding as well. We'll take a look at our first example here. Here's an example of color blindness. So we have to put the X in there to show that it is sex-linked, and it's on the X chromosome. And notice we still use a capital C for the dominant, which is normal, and a lowercase c for the colorblind gene. So the phenotype of our male here, and we know it's the male because of the Y, colorblind, is normal. And the female's phenotype, because they have one dominant C and one recessive, is heterozygous as the genotype, but the phenotype is normal as well. And what will the offspring look like? Well, just so you know, the female, because it has one of these recessive alleles, is known as a carrier. You can't have a carrier male because whatever gene they have on their X chromosome is the only allele that they have. So if we go ahead, we can write these out. We'll put the mother there, the XCs from the mother, big XCs. We'll put the little XCs from the mother there. And C is really not a good letter, but that's what they tend to use for color blindness. Then over here we have the big C from the father in both those cases. And then we have the Y, which makes things interesting. So we actually get different ratios sometimes for the males and females. In this case, we know that this female is normal, 2 big C's. This female is normal, but a carrier, heterozygous. So 100% of the females are normal. This is our phenotype again. And then in the males, we've got 1 normal and 1 colorblind. So for males, we've got a 50-50 ratio of normal to colorblind. And this is exactly why we tend to have more males that are colorblind than females that are colorblind. And if you ask around your family or one of your friends' family, I think you'll find that that is often the case. So the female carrier can end up leading to a male who is colorblind. Notice it doesn't matter what allele the male has on their X chromosome. That is not going to affect what a male child looks like because the male only passes on a Y chromosome to its male offspring. And so there is the summary of our chart there, and you can see that all worked out. So once again, here is a carrier, and here is a carrier, and here's our one lone colorblind person in the bunch there. Now for hemophilia, we'll use a separate gene. The H's work a lot better than C's because they're easier to see. Big H is normal. Notice in this case we have a female carrier, and we have a male that has hemophilia. That lowercase h, there's no other allele here to cancel that out, no dominant allele, because there isn't an allele on the Y chromosome because it is all short and stubby, like we saw before. So we've got a hemophilic male and a carrier female, which is normal, has the normal phenotype, no symptoms there. And so when we go ahead and fill out our Punnett square, we'll see that our one male here is hemophilic and our one female is hemophilic, and that both of these two are normal. And so in this case, we actually have a 50-50 ratio or 1-to-1 ratio of normal to hemophilic for both genders. So in this case it doesn't matter if you're male or female because all the females are going to get that hemophilic gene from the dad. So there's another example of sex-linked traits, and you'll have a few problems to work through on your homework. Just use your Punnett squares and be diligent, and I'm sure you'll do fine.